Welcome. I am Btech Patel from Dry University. My topic is ultrasonic sounds. First is introduction of ultrasonic. What is ultrasonic? Ultra is beyond and sonic means audible range. Then properties of ultrasonic sound, ultrasonic waves, which is the properties it covers. Then production of ultrasonic sound, by which methods we can produce the ultrasonic sound. Then applications of ultrasonic sound and working problem. Introduction to ultrasonic. First, the word ultrasonic is combination of ultra and sonic. Ultra is beyond the audible range or beyond, and sonic is sound. Beyond the ultrasonic sonic range is called ultrasonic sound. It has frequency above the 20,000 Hz. The field of ultrasonic have applications in imaging, detection and navigation. Then broad sectors of society is used mostly in medical, industry and military for ranging and navigation. Then properties of ultrasonic sound. First is high energy. It has very high frequency, so it will contain very high energy. Just like ordinary sound, it is reflected and absorbed by the material. They can transmitted by long range distance, because it have high frequency, it will cover the long distances. Then arrangement of the ultrasonic sound, which is from the stationary waves of ultrasonic sound. It serves the diffraction, and the method is called diffraction of acoustic grating. The production of sound is provide the heat to the substances. When we apply the ultrasonic sound on the substance, then it will absorb the ultrasonic sound and produce the heat. Then ultrasonic sound production. There are two methods of production of ultrasonic sound. First is magnetostriction and magnetostriction generation of ultrasonic sound, and second is piezoelectric generation of ultrasonic sound. First, magnetostriction. In magnetostriction method, we use magnetic field. By magnetic field, alternate change of magnetic field, the length of bar, iron, nickel and cobalt, we will use ferromagnetic material for magnetostriction. It will change the length like this figure, and by changing this length rapidly, we will produce ultrasonic sound. This effect is called magnetostriction. This is the simple structure of arrangement. There are N and S, north and south pole of magnetic field. When we put a ferromagnetic bar like iron, cobalt and nickel, the bar will change the length rapidly by changing magnetic field. And the criteria for production of ferromagnetic materials ultrasonic sound is, we have to give or apply magnetic field parallel to the bar like this figure. This is the simple construction or circuit for magnetostriction ultrasonic generation. There are two coils. First is primary and secondary coil. They will produce the magnetic field. First is N and second is S. It will follow the Lenz's law for direction of magnetic field. When we apply magnetic field by high tension voltages, magnetic field will change rapidly and bar will change length rapidly. This changing in length is above the 20,000 vibrations, so it is called ultrasonic wave. or ultrasonic frequency. This is the simple construction. XY is the rod of ferromagnetic material like Fe, Co and Ni. Then we have to use magnetic field for production of ultrasonic sound. Alternating magnetic field means changing magnetic field. It will produce the ultrasonic vibrations, because when we change the magnetic field direction of magnetic field, the domains of magnetic domains of the ferromagnetic bar will rapidly change. The frequency of this circuit is depends on the capacitor and inductor which we will use in circuit. It is called tank circuit. This is the equation for calculating frequency by production of ultrasonic sound. We will use number of vibrations produced is equal to the length of bar. It is directly proportional to the Young modulus of the bar, density of the bar and length of the bar. N is equal to 1 by 2L under root Y divided by rho, where L is length of rod, Y is Young modulus of the rod and rho is density of the rod. Advantages of this method is very simple and low cost. We will produce this circuit for ultrasonic sound production. It is very simple construction and easily available, low cost. And second, low ultrasonic frequencies will generate by this method. Disadvantage is we can't get ultrasonic vibrations above the 3 megahertz or 3000 kilohertz. It will depend on the temperature, because when we increase the temperature, length of bar will increase. So length is depends directly on the number of vibrations. So temperature is effect on the vibrations. Then second, there will be losses by hysteresis loop, because we use magnetic field, so it will produce hysteresis loop in ferromagnetic substances, so it will losses in magnetic field. Second method, piezoelectric generation of oscillator. Piezoelectric generation will depend on the vibrations of piezoelectric substances like quartz. Quartz is a piezoelectric substance on which if we apply the electric field, then it will vibrate rapidly. It is number of vibrations is above the 20,000 hertz, means we produce the ultrasonic sound by piezoelectric material like quartz. As shown in figure, when we apply voltage to the crystal of quartz, it will vibrates rapidly and it will generate the vibrations. This method is called inverse piezoelectric effect, and piezoelectric effect is when we apply the pressure on the crystal, then it will produce the voltage. It is the piezoelectric effect, and when we apply voltage and it will produce the vibrations by the electric pressure, then it is called inverse piezoelectric effect. This is the circuit for generating ultrasonic sound by quartz crystal and using piezoelectric effect or inverse piezoelectric effect. Between AB plates there is a quartz crystal. When we apply high tension voltage, the electric field will change or current will change. By this current we will change electric field on the AB plates, and this electric field changes will produce the vibrations and apply the pressure on the piezoelectric bar or piezoelectric crystal of quartz. This crystal will affect by this pressure and it will change its size or volume. When high tension voltage will applied, then it will produce the frequency. Frequency F is equal to 1 by under root 2 pi L C. This equation gives you frequency which will produce by quartz. N is number of vibrations which will produce by piezoelectric material. P is overtone. Overtone means how much crystals we use for this circuit. If we use one crystal, then it is 1 overtone, P is equal to 1. If we use two crystal, then both have different frequencies and both have overlap tones, so it is P is equal to 2. Y is Young modulus of piezoelectric material, and rho is density of piezoelectric material. L is length of piezoelectric material. By this method we use 5 crystals and we will get 100 multiple frequencies, means we get resultant 500 megahertz. It is higher than magnetosection method, so we will get high frequency compared to the magnetosection method in piezoelectric effect. Disadvantage, it is very costly. The bar of quartz or crystal of quartz is very costly, and shaping and cutting of the size of quartz is very tough. Detection of ultrasonic sound. In detection of ultrasonic sound, first is piezoelectric detector. In piezoelectric detector we use piezoelectric effect. When we apply the ultrasonic sound on the piezoelectric substance, it will produce the electric field by ultrasonic pressure. Ultrasonic pressure will generate the voltages, and by this voltage we can find the ultrasonic sound which have some frequency above the 20,000 hertz. Kunz tube method. In Kunz tube method, there is a tube in which we have put a lycopodium powder. This powder will vibrate when we apply the ultrasonic sound, and these vibrations are calculated by detectors, and we can find the ultrasonic sound frequencies. Then third method is thermal detector. Thermal detector is used as a, like platinum plate is a thermal detector. When we apply ultrasonic sound on the platinum plate, it will absorb the ultrasonic energy and it will convert it into heat energy, and when platinum is heated, the energy of this heat we will calculate, and by this calculation we find the different energies for different ultrasonic frequencies, and we can find the ultrasonic frequency ranges. Then flame method. In this flame method, there is a narrow flame. On this flame we have to pass ultrasonic sound. When we pass ultrasonic sound, flame will vibrates with respect to the ultrasonic wave, and we can find the frequency by using equation lambda is equal to C by F, and we calculate frequency of ultrasonic sound by flame method. Acoustic diffraction method. In this method, different frequencies of sound or waves will diffract at a different angle. So when we use this method, we will find velocity of the ultrasonic sound, and velocity V is equal to frequency into wavelength, so we get detection of sound by diffraction method. Applications of ultrasonic sound in engineering. Detection of ultrasonic sound in metals. When we apply the ultrasonic sound, there is a non-destructive testing, means we can't cut this material and it will detect defects. Ultrasonic waves detect the presence of flows in the tube, then defects in the bar, all we will find by non-destructive testing using ultrasonic sound. This is the picture. In this pipe there is a flow of some substances which we have to find how much flow is there. Then there is a CRO which will give you presence of flow, and it is depends on the height of wave which will detected by the amplifier. This is the frequency ultrasonic sound generator. Ultrasonic sound generator will incident to the bottom of pipe and reflect toward the detector. This detector will give signals to the CRO, and CRO will generate the shape of wave or height of wave, and we can find how much flow is flowing from the pipe. Then ultrasonic drilling, as shown in this figure, when we apply electromagnetic field to the ferromagnetic material, it will vibrates rapidly, and we will drill anything like hard metals at a unique time. Ultrasonic welding, same as ultrasonic welding is transfer of heat. When we use apply the ultrasonic sound on the substance, then it will heat and we can join the materials. Ultrasonic soldering, simple like as a welding. When we apply ultrasonic sound on the material, then it will melt by absorbing heat of kinetic wave. This wave will give heat and melt the substance, and we will solder easily by ultrasonic sound. Ultrasonic cutting and machining. Ultrasonic sound has very high vibrations. When we apply these vibrations to the shape of some body, then ultrasonic vibrations will cut that shape as a given. Ultrasonic cleaning. Ultrasonic cleaning, in this method we have one water sink or oil sink or alcohol sink which we have to use as a cleaner, and in a bottom of this sink we will use ultrasonic vibrating plate. When we have to clean the some substances, we will put these substances in the water or alcohol, then we will start the ultrasonic vibrations. These ultrasonic vibrations are very rapid, around 20,000 numbers of vibrations per unit time. These vibrations will clean these substances. Sonar, sound, navigation and ranging. It is used in submarines to detect the objects surrounding the submarine. Sound will propagate towards the direction which we have to navigate. In this direction ultrasonic sound will transmit and reflect after some time. This distance will be calculated by using this formula, d is equal to Vt divided by 2. T is double because traveling of wave is going and coming back. So this time is T by 2 for one direction. V is velocity of ultrasonic sound which we have to transmit. D is distance between two objects. Application of sonar. Sonar is used for ship works, means in ship finding the depth of sea we will use sonar. Then in submarines we have to levelize the submarine on the sea surfaces, because all the sea surfaces are not equal, so at that time we will use sonar. Fish finding, different shape of fishes we will find by ultrasonic sound by using detector like CRO. It is used for seismic survey, like in sea depth there is a metal or diamonds or ornaments which are long ago it reserved in depth of sea. We will find this by ultrasonic sound. Application of ultrasonic sound in medical. In sonographic machine, we will use ultrasonic sound for sonography. Date of the pregnancy, then location of the placenta, then numbers of fetches, physical abnormalities of the human, then sex of the baby, all we will find by ultrasonic vibrations and sonographic machine. Ultrasonic therapeutic applications. In stone operation, we will use ultrasonic sound for breaking the stone in human body. Ultrasound in research, when we have to mix two chemicals, then we will use ultrasonic vibrations and we will mix two chemicals easily. This, and second application is speed up any reaction, then we will use ultrasonic vibrations, then the reaction speed will increase. Thank you.